Okay, so this lesson is on complex numbers. It's chapter 2, section 1. And we are going to first refresh our memory about imaginary numbers. So last year in Algebra 2, you learned about imaginary numbers. And if you don't remember, usually most people say I, because you're going to be using the variable I to represent imaginary numbers. And last year in Algebra 2, you learned that I is equivalent to the square root of -1. Now, what this is going to help us with is up till now this year, if we've come across something like the square root of -4, we've just said no real answer. We're going to be able to simplify this now because we can break the square root of -4 into -1 times 4. And now we know that the square root of -1 is I. So we're going to take an I out, and it leaves me a positive 4 inside, which we all know makes 2, and now we have 2I. So we're going to be able to simplify the square roots of negatives now by taking an I out. We also, if I equals the square root of -1, if we square both sides, that means that I squared is equivalent to -1. So if we ever see an answer like, say, 3I squared, we now know I squared equals -1, so that's equivalent to -3. So we'll be able to simplify those situations as well. So we're going to look at the first examples in your notes. So these, you should have the blank notes at home or at your desk. The square root of -25. The first thing you always want to do is deal with the negative. So we're going to take an I out, which eliminates the negative, and now we have square root of 25. What's the square root of 25? 5I is my final answer. Over here, square root of -32, we're going to take the negative out by taking an I out, and that leaves me with the square root of 32. Now that's not a nice, quick square root like square root of 25, but we can still simplify it. How does it? We break it apart. We're going to find two factors that make 32. What are two factors that make 32? 8 and 4, what's another pair? 16 and 2. 16 times 2, what's the square root of 16? 4. So a 4 is going to come out and join the I, and the 2 stays inside. 4I root 2. So that's how we're going to handle the square roots of negative numbers. We're also going to talk about complex numbers. What does it mean to be a complex number? Well, it means that you're going to have a real part added or subtracted with an imaginary part, a plus bi. So something like 2 plus 3i is a complex number, or 5 minus 4i is a complex number. A lot of people, if I give you 3i and ask, can this be turned into a complex number? You say, no, it's just imaginary. There's no real part. But what can we add to this imaginary part that would be real, but not change the value in it? 0. 0 plus 3i makes a complex number. So we can turn imaginary numbers into complex. What about the real number 6? Can we turn it into a complex number? What could we add to the real part so that there would be an imaginary part, but it wouldn't change the value in it? 6 plus 0i is a complex number. So all it means to be a complex number is that you have a real part and an imaginary part. And when we simplify with complex numbers, we're going to do so just like we would if it were the variable x. We're going to add like terms. We're going to do things like FOIL. None of that changes. The difference is now when we see things like I squared, we know that it means -1. So for this first one, all we want to do is add these two complex numbers. What are we going to add together? We're going to add the real parts together. So the 5 plus the 7. And we're going to add the imaginary parts together. So we end up with 12. -11i plus 4i is -7i. And that's your final answer. Come over to the letter B. What are we going to do first? Well, there's a subtraction sign in the middle. What should I do about that subtraction sign? I need to distribute. So first thing I'm going to do is distribute. So I'm going to go through and distribute and get +11 plus 6i. Once I've distributed, I'm ready to add my like terms. So negative 5 plus 11 is 6. I plus 6i is 7i. Final answer. So let's move to letter C in our notes. So for letter C, we have 4i times 3 minus 5i. What am I supposed to do with the 4i? I'm supposed to distribute. Good. Distribute. So what's 4i times 3? 12i. What's 4i times negative 5i? That makes negative 20i squared. Well, what did we learn in the beginning of today's lesson? I squared is equivalent to. I squared is equivalent to negative 1. So that's the same as negative 20 times negative 1. What's negative 20 times negative 1 make? Positive 20. When we write our complex numbers, we usually write the real part first and then the imaginary part. But these are equivalent. They're the same thing. Come over to D. What do you think you're going to do for D first? You're going to FOIL. So we're going to FOIL. So we get 7 times negative 2. And we get 7 times negative 5i. Then we do our inside. So negative 3i times negative 2. And then last, negative 3i times negative 5i is 15i squared. Now what do you do? Okay, we know I squared. What do we know I squared is the same as? That's the same as negative 1. So what's that going to make? It's going to make negative 15. We have like terms. Negative 35i plus 6i gives me negative 29i in the middle. And finally, what do negative 14 plus negative 15 make? They make negative 29 minus 29i is my final answer. Now, when we come over to E, letter E, there's actually 2 ways to solve letter E. Most, tell me one way. You can FOIL, just like D. We could FOIL this and get the right answer. That would not be wrong. It'll give you the right answer. It will be a little longer than if you notice what pattern is 3 plus I times 3 minus I. Where have we seen that pattern before this year? A plus B times A minus B. What is that pattern? That's the difference of squares pattern. What does the difference of squares pattern make? A squared minus B squared. If you've forgotten your difference of squares pattern, you need to write that in your notes again. A plus B times A minus B makes A squared minus B squared. We've got an A plus B times an A minus B, which means we can go straight to the difference of squares. What's A? A is 3. 3 squared is 9. Minus, what's B? B is I. I squared is I squared. What do we know I squared makes? Negative 1. So 9 minus negative 1 makes 10 is your final answer. So, look out for difference of squares patterns. Will you get the same answer if you FOIL? Sure. 3 times 3 is 9, minus 3i, plus 3i, minus I squared. The 3i's cancel. We end up with the same thing. This is just a little bit faster. If you can notice your difference of squares, it will save you time. So we're coming to a vocab word. Complex conjugates. Where have you seen that word before? At the beginning of the year, we worked with conjugates. When did we use conjugates? We used conjugates when we had to rationalize the denominator. What does that mean? When we had something like this, 2 over 3 plus root 5. What's wrong with that? We cannot leave a square root in the denominator. How did we rationalize it? We had to multiply the denominator by 3 minus root 5, and whatever we did to the denominator, we had to do to the numerator. That was called multiplying by the conjugate. Well, imaginary numbers work the same way. We cannot leave an I in the denominator, just like we can't leave a square root. So we're going to need our conjugates, but we're going to start with a simpler one first. When we had something like 2 over root 3, we didn't need a conjugate. How did we get rid of the root 3 by itself on the bottom? Who remembers? We multiplied bottom and top by root 3. And that gave you 2 root 3. What's root 3 times root 3? A normal 3. See, it got rid of the square root. Same idea here. We have to multiply this by something that will make the I go away. Well, if we multiply root 3 by itself, what do you think we multiply I by? By itself. And whatever we do to the denominator, we have to do to the numerator. 2I times I makes 2I squared. 3 times I makes 3I. What do we know about I squared? I squared is negative 1. So that makes 3I over negative 2. Did we get rid of I? Yes. Over here, however, if we just multiply by the I, don't copy this. I'm just demonstrating what will happen if you only multiply by I, so don't copy me. You're going to end up with what? 2I plus I squared. That's 2I minus 1. Does that help me get rid of the I? No. So we need to multiply 2 plus I by its conjugate. What's the conjugate of 2 plus I? 2 minus I. Whatever you do to the bottom, you got to do to the top. Now look at the bottom. What pattern do you see? A plus I, A minus I, difference of squares. So what's it going to make? A squared minus B squared. Well, what's A? 2. What's 2 squared? 4. Minus, what's B? I. What's I become? I squared. Let's finish the bottom. What do we know I squared makes? I squared makes negative 1. What's 4 minus negative 1 make? 5 on the bottom. Up top, what are we going to do with the 3? We're going to distribute and get 6 minus 3i. So 6 minus 3i over 5 is your final answer. So let's do one more rationalizing the denominator. 7 plus 4i over 2 minus 5i. What do we need to multiply the denominator by to get rid of the I? We need to multiply by the conjugate. Whatever we multiply the bottom by, we have to multiply the top by. What pattern do we see in the denominator? Difference of squares. What's my A? A is 2. So 2 squared is 4. Minus, what's my B? 5i. What happens when I square 5i? I get 25i squared. Let's finish the bottom. What's I squared make? Negative 1. So 4 minus 25 times negative 1. That's going to make 4 plus 25, which is 29 on the bottom. On the top, what am I going to have to do? I'm going to have to FOIL. So we have 14 plus 35i in the middle plus 8i. On the end, what's 4i times 5i? 20i squared. What do we know I squared makes? Negative 1, so that's going to make minus 20. What's 14 minus 20? Negative 6. What's 35i plus 8i? 43i all over 29. So we're going to move on to example 4. In example 4, we have to simplify square roots that have negative. I want everybody to hear this. The first thing you always do is take out the I. Before you add, before you multiply, before you do anything, you always take out the I. So for this example, what am I going to do first? Take out the I. That becomes I root 25. And then what's the square root of 25? 5i. Over here, take out the I root 4. What's the square root of 4? 2i. What's 5i times 2i? 10i squared. What do we know about I squared? Negative 1 makes negative 10. Over to B, what do we do first? Take out the I. So I root 18 minus I root 8. Now, can we subtract those? Nope. So what can we do? We can break